What we're going to do is we're going to graph using the greatest common factor and the special factoring pattern. So the greatest common factor, what we're going to do is we're going to look at the two terms and we're going to see what is the largest number that goes into both of them. So 2 and 6, it would be 2. So 2 is our greatest common factor. For 3x and 5x, it's not the 3 and the 5, but they both have an x. So the greatest common factor would be the x. For 6x and 12, 12 doesn't have an x, so we're not going to put an x, but for 6 and 12, it would be the 6. Now, for 2x squared, 10x, and 20x cubed, all of them have an x, and all of them are even, so they're all divisible by 2. So it's going to be 2x. Now, what we're going to do is we're going to find the greatest common factor for the first two terms. And so 5x and 10, it would be 5. Now, after we find the greatest common factor, what we're going to do is we're going to put what's left over. Now, when we're factoring out, it's like dividing. So if we were to divide each of these by 5, what would be left over is an x minus 2. And so when we factor this, that right there would be our answer. So in the same way, if we look at letter B, what they have in common would be a 2. And when we factor out a 2, remember it would be like dividing each of these by 2. What we're left with is a 3x plus 2. For the next one, we're looking to see what they have in common. We see that they both have a 10 in common, and they both have an x in common. Now, when we factor, once again, it's like dividing. So if we were to divide each of these by 10x, we have an x remaining. And then for the second term, what we have is a 5. Now, looking at letter D, this time we have a trinomial. When we have a trinomial, what we have to do is we have to make sure that all 3 of these terms have something in common. So in this case, all of them have a 2 in common. So if we were to divide each of these by 2, we would have x squared minus 2x minus 4. For the next one, what we're going to do is we're going to see what they have in common. And it looks like a 3, but that 7 keeps it from being a 3. So all they have would be an x in common. So we factor out an x. Now, if we divide each of these by x, that means they have one less x. So this would be 3x. This would be 27x squared. And that would be plus 7. Try letter F and see how you do. So looking at letter F, we see that they have a 4. 4 goes into each one of those. And they also have an x. So we factor out a 4x. Now, if we were to divide each of these by 4x, what we are left with is a 2x squared. And then we have plus 6x. Now this one, a lot of students will put 0. It's not 0. We're dividing it. And 4 divided by 4 would give us a 1. So we have a 1 for that one. And that would be our answer. Now that's factoring using the GCF. Now what we're going to do is we're going to look at our special factoring pattern. This is actually called the difference of squares. Why it's called the difference of squares is because we have two terms that are squared and we're subtracting them. Whenever we have two terms that are squared, what it does is it factors to a minus b and a plus b. Now, in order for this to work, what we need to do is we need to find the square root of each of our terms. So what I have down is all the square numbers. These are all numbers that when you multiply them by themselves, it gives us that value. So 1 squared gives us 1. 2 squared gives us 4. 3 squared gives us 9. So on and so forth. So when we're looking at this, whenever we have two terms and there's a subtraction sign, and we could find the square root of each one, it becomes a special factoring pattern. x minus 2 and x plus 2. So for the next one, notice that we can take the square root of each one. So that becomes x minus 3, because the square root of 9 is 3, and x plus 3. One of the binomials has a subtraction sign. The other one has an addition sign. If we look at the next one, if we take the square root, it would become x minus 6 and x plus 6. Now, this next one, notice that it doesn't have a subtraction sign. It only has an addition sign. So this difference of squares only works if it's a difference. So this is not going to work, so it's not factorable. Sometimes people will call it prime. So if ever you see the word prime, we could think of a prime number. It means that there's no other factors than 1 in itself. So you could put not factorable. You could also put prime. Either one means the same thing. So take some time and try those next 4 and see how you do. Letter E, we could take the square root of each one, and that gives us 3n minus 1 and 3n plus 1. For the next one, if we take the square root, it gives us 4w minus 7 and 4w plus 7. For the next one, notice that 3 doesn't have a square root, so this is not factorable. Or you could put prime. For the next one, we have a square root of 100 and we have a square root of 81. So it's 10x minus 9y and 10x plus 9y.